Hello Internet, Winston here. I wasn't gonna make a video this week because I've been busy working on this, but last week one of my friends approached me with a project idea I couldn't turn down. His dad is an avid woodworker and builds all sorts of things like this box. My friend asked me if I could do anything with my CNC to make said box a little more interesting. He suggested an artistic engraving of some sort, but couldn't elaborate beyond that. It was a very open-ended question. Having just conveniently finished a couple of basic carving projects, I was fairly comfortable taking on this sort of challenge. After a bit of research, I discovered these designs called calligraphic elements, and as it turns out, they're actually a pretty big thing if you're at all knowledgeable about arts and crafts. You can easily find them in vector graphic formats, which means you can scale them as large as you want without losing quality, and better yet, many of them are free. Unfortunately, the majority of the calligraphic elements I found were encapsulated PostScript files that I couldn't open in Inkscape. But there are plenty of ways around this problem, and I was able to convert my desired design into an SVG without much trouble. I did this by exporting high-resolution images of my desired patterns into Inkscape and auto-tracing them. But I hear there are plugins that'll give Inkscape EPS file compatibility, which is probably a better way to do this. Since I'd be carving designs out on pre-cut pieces, it was important that I initialize my Shapeoko at a known position relative to the panel I was engraving. I found it easiest to reference everything from the center of each panel, instead of trying to calculate how much margin I would need around my design. For carving out fine details, I once again turned to V-bits. I purchased a pack of 10 no-name carbide bits on eBay a few weeks ago. They were marketed for etching PCBs and have a 45-degree taper with a 0.1mm point, which in engineering terms is pretty darn sharp. The eBay page for the exact item I bought is no longer active, but if you want to see what I'm using, I put a link in the description to a comparable item on Amazon. For my first few cuts, I opted to simply run a follow path operation on my vectorized calligraphic elements. By choosing a shallow cut depth, I was able to carve details much finer than my 1/16 inch end mill could manage. Some of the patterns took longer than others to machine. The decorative border I put around this company name on the bottom highlighted one of the weaknesses of MakerCam's pathing strategy. It goes through each SVG layer and uses a raster-style pass to identify geometry to cut. For this job, a lot of time was wasted traveling between points. It wasn't too terrible though. Everything finished in around half an hour, and I really like the faux stitching effect on the design. It's completely out of place on wood, but it's just such an interesting texture that I think it actually looks good. After a couple successes, I decided to try something a little different. Instead of just tracing the outlines of each sweep and swirl of the calligraphic elements, I wanted to do them as pockets. With V-bits, this might seem impossible. After all, they taper down to a single point. How could you possibly mill out a flat surface with them? In this case, loose tolerances are your friend. The point of your V-bit isn't perfectly lined up with the axis of rotation of your spindle. We usually call this runout and do everything in our power to avoid it, but in tiny amounts it's hardly noticeable, and it effectively gives our cutting bit the ability to machine a small but measurably wide line. For my last project, I know my Dremel has a slight deviation of plus or minus 1/100th of an inch. This means my V-bit should be able to machine a 0.2 inch wide strip at the bottom of a 45-degree sloped valley. Just to be conservative, I told MakerCam that I was using a 0.1 inch diameter end mill with a generous amount of step overlap. The end result is a carved calligraphic element with a varying stroke width. Now I want to be clear that what I'm doing isn't nearly as advanced as what software like VCarve Pro can accomplish. VCarve can dynamically adjust the Z height of the cutter to achieve varying line widths, as well as follow the contours of square corners. What I'm doing is purely 2.5D and decidedly more basic. Here's what the box looks like after being put back together. The two side panels have matching designs for symmetry, while I experimented with two different designs for the front and back. Word on the street is that my friend's dad is quite pleased with how this experiment turned out and intrigued by digital fabrication. I, on the other hand, am now trying to figure out how to CNC myself a box like this. And that's it for today. Nothing too fancy, just some simple V-bit tests. I'll be back in a couple weeks with a dust and shrapnel containing enclosure for my Shapeoko, but until then, I want to thank you all very much for watching, and hope you guys build something cool in the interim.